Let's go over one of the problems from the homework that may have given a couple people a headache or two. This is for Chapter 6 for the for Chem 101 students. But we're going to go over Boyle's law, and in this problem you do have to do a conversion of units. So we'll talk about that. And don't worry, on the exam you will always be given conversions. So the problem talks about a container, or a lab I think, that has a volume of 2.2 times 10 to the 4 liters. And it has a pressure of 5.4 times 10 to the 3 millimeters of mercury. So I know that this is a unit of pressure because the problem told me. So they say, what is the volume if the pressure was changed to 0.988 atmosphere? So I know that this is a P1 V1 equals P2 V2 problem. How do I know that? Because remember, P, V, T, and N, these are all the things that can vary, right? In this problem, they don't say anything about temperature changing, and they don't say anything about the number of moles changing. So we're assuming that these are kept constant. So what equation do I know that associates P and V together? It's Boyle's law, which is P1 V1 equals P2 V2. So let's define P1 and V1. So I usually think about this as the before, and this is the change. So is there a pressure that they give me before we have, is there an initial pressure? Yeah, they give me an initial pressure of 5.4 times 10 to the 3 millimeters of mercury. Is there a volume that we are starting with? Yes. 2.2 times 10 to the 4 liters. What is the pressure that we're ending with? 0.988 atmosphere. And then what's the volume that we're ending with? That is our unknown, right? What is the volume if the pressure is changed? Okay, so this is our only unknown. So what problem do I have with this? My pressures are in units of millimeters of Hg in atmosphere. So if I plug those in, are they going to cancel out? No. So your pressures have to be in the same unit before you can even plug them in. So how do I do that? I know that 1 atmosphere is equal to 760 millimeters of Hg. You would absolutely be given this conversion, right? So let's turn this into atmospheres, shall we? So I'm given 5.4, and I'm just going to 5.4 times 10 to the 3 millimeters of Hg. Put it over 1. And then I'm given this conversion. So do I want 760 millimeters on the top or the bottom? I want it on the bottom, right? Because I want the millimeters of Hg to cancel out, and my desired unit is what? Atmosphere. Okay, so let's type this into our calculators. Essentially, we're going to be having 5.4 times 10 to the 3, and then that is going to be divided by 760. So it looks like we're talking about a pressure of 7.1, we'll say 11 atmosphere. So I'm going to write that up here, 7.11 ATM. And you know what? I'm going to box it in because I like that unit now, because it agrees with this unit. And liters, if this is in liters, what's my answer going to be in? It's going to be in liters, right? So let's go ahead and plug that in. So my P1 is now 7.11 atmosphere times V1, which is 2.2 times 10 to the 4 liters, equals, my P2 is 0.988 atmosphere times x, right? P1 V1 equals P2 V2. So then I can multiply these two together and then divide by 0.988. So 7.11 times 2.2 times 10 to the 4. Get a big number, and then I divide by 0.988. So this is one. Remember, to do an exponent you have to move it over to a decimal. So this is basically 1.58, or we'll call this 1.6, right? I think the answer asks you to do it in 2 significance, but we will do it in 3, and just so you can abbreviate if you need to. But how do I turn this into an exponent? 1.58 times 10 to the 1, 2, 3, 4, 5. 1.58 times 10 to the 5. Liters is the answer. Why? Because this was in liters. So this will be in liters. 0.58 times 10 to the 5. So if the answer wants only 2 significance, you'd say 1.6 times 10 to the 5 liters. You could say that if it asks you for 2 significance. So that is how you do that problem. If you have to do a unit conversion, you will know, because these will not match up and you cannot plug them in to this equation until they agree with each other. If they were both in millimeters of Hg, that's fine. If they're both in atmospheres, that's fine. As long as they're the same unit of pressure, that's all you need. I do hope that this helped. I know that this problem was a little bit tricky.